Hi everyone, so today I'll be talking about oxidation of alcohol. Alcohols are oxidized by warming it up in an acidified solution of dichromate 6 ions, which are then reduced to chromium 3 plus ions. So it's dichromate 6 because if you calculate the oxidation number, it is plus 6, and the oxidation number here is plus 3. And because of this, the solution looks orange, but then once it is reduced, it looks green. And it is very common for the IB to ask students to write a redox equation of dichromate ions to chromate 3 plus ions. But a little tip, this whole equation I written out here can be found in the formula booklet. So let's get into oxidation of alcohols. But before I go straight into the oxidation, I'll go over the types of alcohols, and this is very, very simple to do. So right here, I have drawn 3 isomers of butanol. So this is butan 1-ol, this is butan 2-ol, and this is 2-methyl propan 2-ol. So, to know the type of alcohols, you just have to see how many carbons are attached to the carbon with the hydroxyl group. So with butan 1-ol, there is 1 carbon that is attached to the carbon with the hydroxyl group. In butan 2-ol, there is 2 carbons. And in 2-methylpropan 2-ol, there are 3 carbons. So then with this, you can easily tell what type of alcohol it is. Since there's 1 carbon, it is a primary alcohol. And when there's 2, it's a secondary alcohol. And 3 is a tertiary alcohol. And this is important as it affects the extent the alcohol can be oxidized to. Okay, so I'll start with primary first. Butan 1-ol is first oxidized to butanal. So, looks like this. And it is an aldehyde as the carboxyl group is at the end of the compound. And then it can be oxidized again to a carboxylic acid. So then it becomes like so. Then it becomes butanoic acid. And this is the extent a primary alcohol gets oxidized to. Okay, and for the secondary alcohol, we also see an oxidation of the OH group becoming a hydroxyl group becoming a carboxyl group. But it's not an aldehyde, it is a ketone, which are functional isomers, structural isomers of each other. And then it actually cannot become a carboxylic acid because carboxylic acid is at the end of the group, so it doesn't go further oxidation. And then for tertiary alcohols, it doesn't go further oxidation at all. And you can see there's a similarity on why. It's because the carbon that the OH group was attached to before, there are no more hydrogens for the dichromate 6 ions to reduce, and therefore cannot be further oxidized, because you have to remember oxidation is also defined as loss of hydrogens, and there are no more hydrogens to be lost. This is the exact same for the carboxylic acid at the end of the oxidation for primary alcohols. You see there are also no more hydrogens left. Well, on the oxygen, but not to the carbon atom itself. So once you notice that, you know we can never go further oxidation. And it is that simple. There are still some extra details I will talk about the oxidation of alcohols. There might be questions on experiments when you do oxidation of primary alcohols, and if you just want to get the aldehyde product from the primary alcohols, you can distill it out, and it's because it lacks the hydroxyl groups, so there are no hydrogen bondings. That means it has a lower boiling point. And then for the aldehyde to be further oxidized, you put it under acid reflux. And you do it under reflux to ensure no aldehydes do escape due to its lower boiling point. Okay, after this, I'll add some practice questions so you know how the IB will question you on oxidation of alcohols. Okay, so here are some practice questions related to alcohol oxidation, and just pause the video and work on it. Then I'll post the answers in the description of the video. So these are the first two, and then these are the second two. Okay, thank you for listening.